1.4, fractional expressions. Rational expressions are expressions with the numerator and denominator as polynomials. When you simplify a fractional expression, you want to cancel the common factors. So, in our first example, we have x squared minus 9 over x squared plus 9x plus 18. When you have a fraction like this, you want to factor the numerator and denominator. So we see right here in the numerator, x squared minus 9, that's the sum and difference pattern. X plus 3 times x minus 3. Over x squared plus 9x plus 18, that's a trinomial. What multiplies to 18? That adds to 9. That's 6 and 3. So it goes to x plus 6 times x plus 3. We are now in factored form. And we see we have the quantities x plus 3 over x plus 3, and those can cancel. So we have remaining x minus 3 over x plus 6. You cannot cancel out the x's, you cannot reduce the 3 and 6 because you don't know what x minus 3 is or what x plus 6 is. So this is your answer. You cannot simplify it anymore. When you are multiplying rational expressions, you need to break down each section individually and then rewrite it all in factored form. So section A, top left, x squared plus x minus 12, what multiplies to negative 12, adds to 1. That would be 4 and negative 3. So A becomes x plus 4 times x minus 3. Section B, lower left, 5x plus 10. It's a binomial, so you look for GCF, which is 5. Take out the 5. You have x plus 2 remaining. Top right, C, negative x minus 2. Take out the negative 1. You're left with x plus 2. And section D, what multiplies to 4, that adds to 1, that would be, that adds to 5, that would be 4 and 1. So x plus 4 times x plus 1. Everything is now in factored form. You look for common factors to cancel. Remember, one factor needs to be in the numerator, the other must be in the denominator. So we see an x plus 4, top and bottom, they cancel. Also see an x plus 2 and x plus 2. So we have left x minus 3 times negative 1 over 5 times x plus 1. Don't distribute, just write the monomial, the constant first, negative 1 times x minus 3 over 5 times x plus 1. This is your simplified answer. When you are dividing rational expressions, you're going to change it because you are dividing by a fraction. You're going to multiply by the reciprocal. So keep the x squared plus x over x squared plus x minus 30. It is now timesing x squared minus 11x plus 30 over x minus 6. It is now multiplication, and you approach it just like the last problem. Factor each section. And then we have x squared plus x. It's two terms. It's not a sum and difference pattern, so you take out the GCF, which is x, and you have x plus 1 left over. B, what multiplies to negative 30 and adds to 1? That would be 6 and negative 5. So it goes to x plus 6, x minus 5, times upper right, x squared minus 11x plus 30. Multiplies to 30, that adds to negative 11. That would be negative 5 and negative 6. So factored form is x minus 5 times x minus 6. And bottom right is x minus 6. It's not a sum and difference pattern. There's no GCF other than 1, so just put it in parentheses x minus 6. We now see that there is some common factors that we can cancel. So we have an x minus 6 and an x minus 6. We have an x minus 5 and an x minus 5. So we are left with x times x plus 1 over x plus 6. There's no need to distribute in the numerator. We can leave it just like this. When we add or subtract rational expressions, we must have a common denominator, and to get the common denominator, it must be in factored form. So x squared plus 4x minus 5, that factors to x plus 5 times x minus 1. X squared plus 7x plus 10, that factors to x plus 5 times x plus 2. And now, to get the common denominator, we need the LCD. We write first the term that's in common, or the factor that's in common, which they both have an x plus 5. And that's the only common factor, so now we write the uncommon factors, and they are multiplying. So x minus 1 times x plus 2. We now multiply the fraction by its missing component. So the first fraction is 2 over x plus 5 times x minus 1. It needs the x plus 2, so on top and bottom, x plus 2. In the numerator only, you distribute. So that becomes 2x plus 4. On the denominator, leave it in factored form. Let's get that second fraction. To have the LCD, we need to multiply it by x minus 1. Because this is an x squared plus 2, put parentheses, and we need to FOIL. Becomes x cubed minus x squared plus 2x minus 2. So that is our numerator for the second fraction. Alright, since we're adding the two fractions, we need to add the numerator. So we find the highest degree, that would be an x cubed. There's no other terms. We got a minus x squared. We got a plus 2x plus a 2x. goes to plus 4x, and we got a 4 minus 2, so plus 2 over the common denominator. Look to factor the numerator. You have x cubed minus x squared plus 4x plus 2. It's 4 terms, so the only option would be factor by grouping, but it does not work. So this is our simplified answer. Our last example is for compound fractions. It's where there's fractions within a fraction. So we have x over y plus 1 divided by 1 minus y over x. When this happens, group the numerator separate than the denominator and write it as a true division problem. So we have x over y plus 1 divided by 1 minus y over x. Work inside the parentheses first. We have an x over y plus 1. We need the common denominator, which is y. So this goes to x over y plus y over y, which becomes x plus y over y. Now let's go to the second set of parentheses, 1 minus y over x. Get a common denominator, which is x. So it becomes x over x minus y over x, which simplifies down to x minus y over x. We now have a fraction divided by a fraction, so we are going to multiply by the reciprocal. So it becomes x plus y over y times x over x minus y. Whenever it's two terms and there's no GCF or sum and difference pattern, group them together with parentheses. They cannot be separated. And there's no common factors to cancel. X and y are not the same. X plus y is not the same as x minus y. So our answer will be x times x plus y over y times x minus y.